Bismillahirrahmanirrahim. Today we are studying the escape velocity. The escape velocity it is clear from the name escape. Escape just to go free of certain force, as it is related to gravity. So therefore we say it is defined as that velocity when it is given to a body on the earth surface, it escapes itself from the influence of the earth gravitational field. So it means there's such a velocity which is when given to a body, the body escapes itself, the body keeps it free from the influence of the gravitational pull. It depends on the gravity strength of the planet, which is G is equal to 9.8 meter per second square for our Earth planet, and the V escape for the Earth case 11.2 multiplied by 10 raised to the power 3 meter per second. And similarly, if you want to convert, and 10 raised to the power 3 mean 1000, if you multiply this by 1000, you are going to open multiplying by 11.2. So it will stretch away, give us 11,200 meter per second. It means that this much velocity, when given to a body on the Earth's surface, the body will keep itself free from the gravitational pull of the Earth. Similarly, on the Moon, as the value of G on the Moon surface is almost 1.6 meter per second square, then the escape velocity over here is 2.3 multiplied by 10 raised to the power 3 meter per second. If you are going to do the same process with this, so it will give us 2300 meter per second, 2300 meter per second. So look at the difference. The difference is quite clear. That is in 11,000 and this is in 2000. If you are 200 and 300 keeping to a side, so 11,000 and 2,000, this is a big difference. The mass is the same. So this is the value of G, which is going to decide that how much velocity is to be given just to keep influence free of the influence of the planet. So the mass is the same and the value of G is going to decide that how much velocity will it need. So similarly, if we are going to the surface of Mars, which is also called Marikh in Urdu, and the Jupiter, so definitely the value of G will be different, and when the value of G will be different, so the escape velocity will also be different. So now let us derive an expression that how this 11,200 or 2,300 or whatever the value will on the surface of Mars or Jupiter. So there must be a formula which will justify that how these numerical values can be obtained. So let there be a body of mass m be displaced from the surface of Earth up to an infinite point in space, which is really the definition of absolute potential energy. The article which I have already provided to you through our college website, and this article has been provided there, so you should study it there and keep in your mind that here if you are facing some difficulty in the reading, so please do use the bigger screen of your laptop, and then you would be having inshallah no problem in reading and in understanding. Everything would be clear. So it means that we have provided the absolute potential energy to the body when we were displacing it from the surface of Earth, and the magnitude of the absolute potential energy, we should again recall that was equal to the amount of work done in displacing the body from the surface of Earth up to infinity. That was G M E divided by RE. RE was the radius of Earth, ME is the mass of Earth, and small m was the mass of the body which was displacing from the surface of Earth up to an infinite point. So this is the magnitude, and we should remember there was a negative sign there also. So the negative sign for the purpose that it was against gravity. So here the magnitude we need the magnitude. So therefore we have taken not the negative sign over here, we have taken only the magnitude of it. Okay, so now the potential energy will be converted to the kinetic energy of the body, that because the body will be moving and this is the amount of work done on it, but this will be converted to kinetic energy because the body would be moving, and this motion is in the form of kinetic energy. And kinetic energy, you know, it is that energy which is given to a body due to its motion, and this is 1 upon 2 mv square. Very familiar equation. And 1 over 2 mv square, so v square escape, as we are interested in the escape velocity, that velocity which is given to a body, and the body will escape itself from the gravitational pull. So we are interested in this one. So I mean the equation number 1 and equation number 2, which the old equations, the equations from which we are already familiar. So therefore, because this has been derived in the last article I have provided to you, and this is the 1 over 2 mv squared from the energy. So next is the, when do matching these two, 1 over 2 mv squared escape in g m m e over r e, equation number 1 and equation number 2. So small m and small m, so masses are there, so masses will be cancelled. So when they are cancelled, so we are having over now the this expression, 1 over 2 mv square, yeah, v square escape divided by 2 is equal to g m has been cancelled, me divided by re. As we are interested in escape velocity, so this 2 in the denominator, shifted it to the right hand side so that it will be multiplied, and we will take it v square escape is equal to 2g me over re. As it is the v square, so taking the square root of both sides, so different it is square of this, so we will come out of it with escape, and this will become under the root 2 g mere under the root. This is equation number 3. So now we are replacing the value, because capital G, yes, it is also a chance because capital G is clear, and 6.63 multiplied by 10 raised to the power 11 Newton meter square per kg square. Mass of Earth is also clear. This is the mass of Earth is a fixed value. Radius of Earth is also a fixed value, which will also come. So when these fixed values, when these constant values, if you are interested to put the values here, so they will also provide you the escape velocity, that one 11,200 meter per second. So we are further going to elaborate, we are going to explain that is it possible to substitute these values g, m, e or r, e by another simplest values? Yes. For this purpose, for substitution, on the right hand side of equation 3, take the body m on the earth surface, for which we can write this is the earth, which radius is re, and the body is lying on its surface. So weight is there, and weight we know it is defined as that force with which a body is attracted towards the center of earth. So W is equal to mg. So therefore we say the weight of the body W is equal to mg. Here is very quite clear. So similarly, on the other side, we can also apply the gravitational force over here, according to law of universal gravitation, that it is the product of the two masses, I mean mass of the body, mass of the earth, and inversely proportional to the square of the distance between them. And it is the radius of the earth and the body on the surface. It means the radius of the earth and the distance between the body small m and mass of earth, that is the same, that is re. So therefore, this is the gravitational force. It means that the weight of the body and the gravitational force, they are the same. So therefore, again matching, for the purpose that we need these values, either this, either this, either this. So when we do compare the equation number 4 and equation number 5, what we get mg, W is equal to mg, and F gravitational. Again mass and mass cancel, small g is equal to gme over re square. So now, shifting gme r is equal to this side, so small g multiplied by r is square and g capital M E. So it means that this GME can be replaced by another simplest values GRE over here because they are equal. So putting this equation number 6 in equation number 3 for the sake of GME, what we get, we escape is equal to that equation I have written again over here is equal to 2GRE. So this is now over here GRE square. GME is equal to GRE square. So GME has been replaced by GRE square. This RE is already present in equation number 3. So one RE and another RE in the one in numerator, the other in the denominator, they will be cancelled. So we would be having one RE. So 2GRE. So if we escape is equal to under the root 2GRE, so it is more simplest. So comparing now equation number 7 with equation number 3, so very clear cut this equation is quite simplest form is that of equation number 3. So anyhow that can be used and that can be used. It will depend on the situation that how and which constant values are given, either the are given or these are given. So whatever the values are given, so this is the simplest one because the value of G on the surface of Earth is 9.8 meter per second square and the radius of Earth, you will remember, you will need it again and again, 6.4 multiplied by 10 raised to the power 6 meter. It is in meter. Okay, you put all these values and multiplying these two with your calculators and taking the square root, so straight away you will get easily 11.2 multiplied by 10 raised to the power 3 meter per second, or if you are going to remove this 10 raised to the power 3 and multiplying by that and some will be cancelled. So after simple multiplication, very clearly we will obtain 11,200 meter per second. So remember earlier stage, initially I had told you that we will need 11,200 meter per second velocity to be given to a body to escape itself, to keep it free from the gravitational pull. So the same thing will happen on the surface of moon if we know the value of G. Similarly, it is possible on the surface of Mars, it is possible on the surface of Jupiter or whatever the planet is. But if we are given the value of G, so we can do it very clearly and very easily. So similarly, you can do many examples on this one in the book. But you see the same formula, but if the radius is given on the surface of the moon in this is G is 1.6, right? So escape velocity, so we escape is equal to 2GRE under the root, right? Over there. But now at the surface of moon, this was we escape, but that was 2GRE under the root when we were talking on the surface of Earth. It is the moon, so definitely G will be for moon, R will be for moon. So different. So 2G 1.6, and that is now you can clearly 1.6 multiplied by 10 raised to the power 6 because that is given over there, that is the radius of the moon. So very clearly we can solve this example. The moon radius is given 1.6 multiplied by 10 raised to the power 6. The acceleration due to gravity is given. G is equal to 1.6 meter per second square on its surface to find the escape velocity on the moon. So it means that whatever the planet is, if we are given the value of G and if we are given the radius of that, because in the formula we do need these two things, so easily we can do it. So but it's quite important just to give you the value of G and the value of RE. So putting these two values there again and taking the square root, so again it will give us 2.3 multiplied by 10 raised to the power 3 meter per second or 2,300 meter per second in this simple numerical where the value of radius is given, where the value of G is given. I am going to revise that. Yes, we can find the escape velocity, the velocity with which a body will escape itself from the gravitational pull if we are given the radius, if we are given the value of G, or whatever the planet is. So you can do it very easily as a good tool. So, okay, this is over. I will also send this video to a college link. Please, you should see it, you should study it, and if there are some questions, so there are also my email, the contact number already you are having, so you can ask any question. I am ready for it. Okay, all the best. In next article, inshallah, we will take interconversion of potential energy and kinetic energy, and this will also provide the work energy principle. All the best. Thank you very much. God bless you.